Can you see the screen now?
Yes, sir.
So here again, similar to what I had drawn on the board. The videos were showing from the other side, as if you are looking from the 23rd September side. In the videos, the tilt was showing on the right, as if you are seeing from the other side. You got that concept, no? There's no doubt on that, I hope so. The tilt was on the right. So this is the same diagram which I had drawn on the whiteboard.
But the sun will always be near to winter solstice.
Yeah, so you can see that one over here also, no? Sun is near to the winter. That is how our ecliptic is designed. You see, sun will remain on any one foci. So in this case, the foci where the sun is the one which is closer to the winter solstice. That reiterates more, that the distance from the sun does not cause the seasons. It is the tilt of the axis. You can see the note written down below. And they said the same thing in the video also, you must have heard. Correct?
Yes, sir.
Yeah, because the distance doesn't change much, no? 90, what was it yesterday? The mean distance was 93 million miles. Maximum was, I think, 94.5. 94.5 and minimum was 92 or 91 point something. So what is the percentage? If the sun is reducing, the distance is reducing by 3 million miles or 90 million miles, what is the percentage? 3 divided by 90. Percentage is only 3%. So if 3.5% the distance is reducing, will it cause so much change of temperature from 45 degrees Celsius to 5 degrees Celsius? It will not cause, no? So the distance is not what is causing the change of season, it is a tilt. Another diagram which is similar to what you saw in the video. So here you see the tilt is on the right. On the left is the June solstice because the northern pole is tilted towards the sun. So the Arctic Circle remains completely illuminated. Which portion is having night? The vertical line, the left side of the vertical line. The left side of the vertical line. The tilted line is the axis of rotation. Arctic Circle will have full daylight 24 hours. Antarctic Circle will have full night 24 hours. Has any one of you been to those high latitudes in the summer or winter? Anyone been north of Norway, Iceland, those areas? Yes or no?
No, sir.
No, sir.
Yeah, so next time if you are going into the higher latitudes, just notice how the daylight behaves. And the right picture, you see the polar axis is the one which is inclined. Due to the gyroscopic inertia, it remains pointing to one fixed direction in space. It remains pointing to the same direction. And now in this case, you see that the Arctic Circle is bent away from the sun. That remains dark all the time during the December solstice. And the Antarctic Circle remains illuminated all the time. So by this you got a very clear idea of the length of the day. In northern hemisphere, summer the days are longer, nights are shorter. And at the same time in the southern hemisphere, it's winter, so days are shorter and nights are longer. All this we have discussed.
Sir, how do we consider days?
How do we consider what?
Change of days, sir. Like it is Monday, Tuesday.
I did not get a question. The days of the week?
Yes, sir.
One day is 24 hours, no? Are you asking about?
No, like, is there any reference point?
Reference point means what? Why Sunday is not a Monday and Monday is not a Tuesday?
So every year that
Can you explain your question a little more? Are you asking why Sunday is not called a Monday and Monday is not called a Tuesday? Is that what you're saying?
so every year 1st of January will not be Monday, na sir. It will change. What is this concept?
Yeah, because
So, like, I'm talking about international deadline.
International deadline. Yeah, when we come to those chapters, time is another very long and complicated chapter. When we come to the chapter time, after maybe next week or something, then I will explain you the time over there. Point is, you need to pay a lot of attention. And since I'm not in the classroom, I need you to pay a lot of attention with focused mind. And also to read. If you read before coming to the class and read again after going back from the class, it will be much easier for you. Because in time also there are so many things which are imaginary. In mathematics and algebra, you know, we always suppose, let this be x, let this be y, suppose. So that way in celestial navigation also, because see the equator, poles, everything is imaginary, man-made. We have made the latitudes and the longitudes. We have given them a sense of direction so that we have a reference point to start our calculations. Similarly, time is also a very, very difficult thing to understand. So we'll come to time and then I will explain you all those things. Okay. So any question on the seasons you have? These are all diagrams, split up diagrams reiterating the same thing what we have seen in the video or in the main diagram. These are equinox, equal days and equal nights all over the world. So days and nights are caused due to rotation, seasons are caused due to revolution.
No, sir, tilt.
Tilt, yes. Revolution and tilt. If there's no revolution, again there's no season. So it's a combination. There's no other new slide over here. All these we have seen. This also explains the fact that the path of the sun is not circular, or the earth, whatever you want to say, that it is elliptical. Because if the path of the earth would have been circular, then the division into those four quadrants, 365.25 divided by 4, all would have been 91.31 days. But you can see over here that spring is 93 days, winter 89, autumn 90 and summer 94. Which means that March to 21st March to 23rd September, if you count, the number of days will be different. And 23rd September to 21st March on the other side, number of days will be different. If it would have been a complete pure circle, then all the four sectors would have been same number of days. Have you understood this point? No, let me explain here. From the equinox to the solstice, and again to the equinox to the solstice. These are the number of days it is taking: 89, 94, 93, 92. If this would have been a perfect circle, then the entire movement from here to here would have been 91.31 days. Here to here would have been 91.3 days, 91.31, 91.31. Understood? Because the circle you can, if you divide this circle into 4 sectors, you will get equal arc. And if you get equal arc, then the time taken to cover the distance will be the same. These are some zones on the geography you must have studied in school. The Arctic and the Antarctic circle is called the frigid zone, very cold. The torrid or the tropical zone, 23.5 degrees on either side of the equator. And then the temperate zones. Not much of a relevance to us over here, unless you want to relate it to some meteorology. Okay, so that brings us to the end of seasons. Any questions, gentlemen? Whichever side I take you, it will be the same pictures, referring to the same thing again and again. Here I can try and show you. Can you see my screen? Apparent motion of celestial bodies.
Yes, sir.
Yes, sir.
By looking at this diagram, can you tell me
Yes, sir.
what time of the year is it? Which period? Summer, winter, which hemisphere?
Sir, summer, sir.
Summer, very
Right.
good. You see the circles that are made, they are bold line and dotted line also. If you see the North Pole circumpolar is full bold line. That means the heavenly body is continuously above the horizon. If I say it is the sun, it means the sun is always above the horizon. The second circle, the dotted line is small and the bold arc is longer. That means longer day and shorter night. The dotted lines are the night, the bold line are the daytime. The middle circle, equinoctial, you can see equal day and equal night. The lower two circles you can see shorter day and longer night. Shorter day and longer night. Since someone spoke about time, just read this line over here. I will explain all these things later, but since we are at it, it might be of some interest to us. The Earth rotates on its axis from west to east, counterclockwise as viewed from the North Pole, completing one rotation in 23 hours 56 minutes 4.1 second of mean solar time. Now this line has got a very deep meaning, very great meaning. When we say time, what is our reference point? From where are we measuring time? How do we get 24 hours? By just looking at the clock? Who made the clock? How did he decide 24 hours? From where he got 24 hours? If we say that the path of the Earth is elliptical and the Earth is revolving all the time, the daylight and the night time is changing. Keeping track of time becomes very difficult. So If the Earth is completing one rotation in 23 hours, 56 minutes and 4.1 second of mean solar time, then what is mean solar time? And how did we make the mean solar time? It is an imaginary time. So we'll come to that again later when we are doing time. Asking good questions. So I'm quite happy that you people are engaged in the topic. What is of relevance? I will take you there. Some topics are not there in a syllabus and some are removed. Okay, just have a look at this picture before I go on to the other explanation. You can all see figure 6.8.
Yes, sir, it is visible.
Okay. In the bottom center, E is the Earth, S is the Sun, and the other circle is the orbit of Venus. Venus, it has been shown in 5 positions: V1, V2, V3, V4, V5. For the purpose of our thought process, let us assume that the Earth is stationary. Earth is not revolving, only Venus is revolving. But actually what is happening? The Earth is also revolving, and this entire sector, what you can see from V5 to V2 on top, that entire sector is also moving along with you to the left. Am I right? Can you imagine that one? Yes or no?
Sir, if the Earth is stationary, right?
If the Earth is stationary, this is the picture in front of you. If the Earth is stationary, this is what will happen if you see in front of you, correct?
Yes, sir.
Yes or no? Yeah. But if the Earth is also revolving, then the entire sector moves to the left. So for our understanding, let us assume that the Earth is stationary and only Venus is moving. You can imagine that or no? Yes or
Yes,
no?
sir.
You can imagine what
Yes,
is the
sir.
harm in imagining. Nothing stops your imagination. Okay. So let us assume that the Earth is stationary and Venus is moving, revolving around the Sun. When Venus is at V5 on the extreme left, maximum azimuth from the Sun on the left. Let me call it the angle of elongation. Maximum angle of elongation is happening at V5. And which is the other maximum angle of elongation on the other side, at which position of
V2.
V? V2, very good.
V2, sir.
Yeah. So when the Venus is at V5, you can see it projected on the celestial sphere at V5, far away. After V5, she is coming to V1 in the center in conjunction with the Sun. And her position on the top is at V1 in the center. And after that, she is going to maximum elongation on the right side V2 and the position V2 on the top. So Venus has swung from one direction to the other direction when you see on the sky. So from your left side, she has come to the right side. In how many days? In the chart, how many days was Venus revolution? 88 days?
Yes,
What
sir.
I don't remember, 88 days maybe. So this will be how many days if you make a rough guess? Less than half, maybe 30 days. Because you can see V5 to V2 is a shorter distance than V2, V3, V4, V5. Am I right?
Venus is 224 days.
224. So less than that one, 224 means maybe 100 days. or 90 days? Yes or no? V5 to V2, how much time she will take? If it is 224 days.
Around 130.
Why 130? V5 to V2 is less distance. V5, V1, V2. That way. The shorter arc. If it is 224, it will take less than half, no? Yes or no?
Yes, sir.
Yes,
From
sir.
V5 to V1, V5 to V1 to V2 is a shorter arc, and V2 to V3, V4, V5 is a longer arc, correct? Earth is stationary. So whatever time it takes, 3 months or so, from V5, like a pendulum, Venus will move on to V2. After that, you see what is happening. V5, V1, V2, V3. Then again, Venus is going inside the arc towards the sun. Then she's going to V4. Then she's going to V5. So if the Earth would have been stationary, Venus would have been visible in the sky only between the locations V2 to V5. Have you understood this movement of Venus? Because this
Yes,
is
sir.
important to understand the next topic. Okay. The elongation of a planet or the moon. What is elongation of a planet? See the definition. It is the angle at the center of the Earth contained between the center of the Sun and the center of the planet or the moon, whatever, measured along the plane of the ecliptic. You are comfortable with this diagram, or shall I draw it on the board?
So draw it on
Sir,
the board.
on the board.
On the board, okay. Okay, then write down this question and then we will solve this one after I explain on the board. In the meantime, just write down this question.
The board is not visible.
Yeah, I have not switched on the camera as yet. Once you say you're done with the question, then I will switch it on. Have you written the question?
No, sir.
लिख लो. Okay.
सर लिखा
Can
नहीं
you
था
see the
पूरा
board?
क्वेश्चन.
Pardon?
सर क्वेश्चन नहीं लिखा था।
Question, sir.
काफी टाइम हो गया। क्वेश्चन चलो बाद में कर लेंगे क्वेश्चन, डोंट वरी, आई विल डिक्टेट द क्वेश्चन। कैन यू सी द बोर्ड नाउ वेरी क्लियरली? अभी क्या दिख रहा है आपको? बोर्ड दिख रहा है नहीं?
हाँ जी सर।
सर दोनों, यस सर,
दिख रहा है सर।
अभी ठीक है बेटा? ओके,
यस
this is the sun, the red one, green one is the earth, and Venus is the blue one. We said that Venus is going around, we will imagine the earth is stationary. So Venus, sun and the earth. Yesterday what did we say? At the time of maximum angle or the elongation, this will be a tangent, EV will be a tangent to the circular path of Venus. So the tangent to the circular path of Venus, and if you drop a line from the center of the sun, it will be perpendicular. So this is geometry. If you want to find the distance between the sun and Venus, what should you know? We know the distance from Earth to the sun is 93 million miles. The distance SE is equal to 93 into 10 to the power 6, 93 million miles. If I say the maximum angle of elongation is 47 degrees, can you find out the distance of Venus from the sun for me? Yes or no?
So this 47 degree, it's angle of elongation of Venus or Earth?
Venus. Venus is getting elongated, no?
No, sir. Yeah, 47 degree Earth to Venus angle, है ना, sir?
Earth to Venus. No?
Yes, sir, yes.
The question, if you would have read, if the greatest elongation of Venus is 47 degrees, calculate the distance of Venus from the sun, assuming planetary orbits to be circular and coplanar, and Earth is 93 million miles from the sun. Why is there a doubt in this one?
Yes, sir.
This angle is 90 degrees due to geometry. SVE, angle SVE is 90 degrees because any tangent to a circle makes a right angle to the radius of that circle at that point. Yes or no? So it's we can measure the angle of elongation of Venus. If you take a bearing of the sun and bearing of Venus, and every day if you take it, you will know when it is maximum. So we know that the maximum angle of elongation of Venus is 47 degrees. Practically we can see this one, no? And if I tell you that the distance from the sun is 93 million miles, can you tell me the distance of SV? Yes or no? Simple trigonometry, gentlemen.
Yes.
Sin theta is equal to perpendicular by hypotenuse. Yes or no?
Yes, sir.
So sin 45 is SV upon SE. So what is
47 one?
Yeah, 47 whatever. मेरा मिस्टेक जल्दी पकड़ लेते हो तुम लोग. हाँ, जवाब नहीं देते लेकिन. Sin 47 is equal to SV upon SE. So what is the distance of Venus from the sun?
So 68 into 10 की power 6.
68 million miles. Very good. And what is the distance between Venus and the Earth? How will you know the distance between the Venus and Earth?
The cos 47 equal to Venus, the distance Earth upon Sun, Earth distance Sun.
कैसे निकलेगा वो?
The cos theta equal to base upon hypotenuse.
You mean to say EV? EV is the distance you mean to say?
Yes, sir.
लेकिन वो तो दूर चला गया.
सर tan थीटा से निकलेगा.
उस समय का distance, but which is the actual distance? Closest distance तो ये है ना? What is the closest distance between Venus and Earth? दोनों को minus कर दो.
The distance of Venus minus distance of Earth from the
Closest distance जो है इस conjunction में रहेगा. Earth का तुमको मालूम है, ये तुमने निकाल लिया, ये तो circular path है, तो ये same रहेगा. SV is equal to SV1. कभी कभी क्वेश्चन में ऐसे भी आ जाता है. अर्थ और वीनस का डिस्टेंस बता दो व्हेन दे आर क्लोजेस्ट. सो SV1. अगर बोलेगा उधर वाले कंजंक्शन में, इंफीरियर कंजंक्शन में बताओ, तो ऐड कर देना वो डिस्टेंस, ये डिस्टेंस को ऐड कर देना इधर. ठीक है. तो यू कैन डू दिस ट्रिग्नोमेट्री.
Yes, sir.
Have you read that book or no as yet? Nutsell Series 8, Spherical Trigonometry. You must be doing that in the Great Circle.
Sir, it is going on. अभी तक complete नहीं हुआ.
Complete नहीं हो, चल रहा है ना?
कुछ
हाँ.
टाइम से भी
Start
क्लासेस हो
हुआ
रही
था
सर
sir.
स्टार्ट ही हुआ था सर.
Start ही हुआ था sir.
हैं 2 वीक से.
But try to revise whatever you know from your school days or pre-C days. जितना जल्दी. See, because so many topics are slightly interconnected here and there, you know. So the reference will always keep coming up. So this elongation of a planet is clear to you, this topic? The definition. And the calculations. The second question over there, exercise. If the distance of Mercury from the Sun is 0.3871 of the distance between the Earth and the Sun, find the maximum elongation of Mercury. तो ये मेरे लिए तुम लोग करना कुछ होमवर्क.
सर दिखा दी क्वेश्चन.
दिखाया नहीं, बुक है तुम लोग के पास से नहीं है. सो
Yes, sir.
ठीक है. हाँ, मैं स्क्रीन शेयर कर लेता हूँ. Can you see this exercise 6? If the distance of planet Mercury from the Sun is 0.3871 of the distance between Earth and the Sun, find the maximum elongation of Mercury. ये होमवर्क लिख लो. अब 2 होमवर्क है तुम्हारे पास. एक तो वो कांस्टेंट निकाला नहीं, बहुत लड़कों ने, खाली एक ने बताया. I have a class on Thursday, कल नहीं है. Thursday morning when we meet, you must give me the answers of both the questions. Find out the maximum elongation of Mercury and what is the constant for Kepler's third law. I wanted to take this topic now. Venus is a morning and evening star.
Sir, question लिखना है.
Pardon?
Sir, question लिखना है sir. ऊपर
नहीं,
scroll करो.
एक लाइन का क्वेश्चन है, लिखो जल्दी. दिखाई दे रहा है बोर्ड मेरा? शेयरिंग द स्क्रीन. कैमरा बंद कर देता है. Everyone done with the question? Okay, I wanted to complete this topic today. Venus as a morning and evening star, but only 5 minutes are left, so I'll just quickly try and show you something over here. But I will cover this again, so maybe we'll understand much better. It takes a little time to understand this one. So 6.4, हाँ ये आप लोग पढ़ के आना. Again, this is another homework for you, but I will try and explain something now. So Thursday, next class, after explaining Venus as a morning and evening star, I will start the Earth Moon system. ये सारे topics थोड़े awkward हैं, so if you read this and come, it will be better. You can understand better because Moon is a very complicated heavenly body. जितना नजदीक body होता है Earth के, उतना complicated है उसका movement. The stars are the simplest. They are very far away. They are so far away that if they are revolving or rotating or doing whatever in their solar system, it doesn't make a difference to us because we cannot see the movement of the stars. They are so far away. So for us, they are very simple bodies. But the bodies which are close to the Earth, like the sun, the planets, the moon is the closest. So जितना close heavenly body है उतना complicated उसका movement है. In the almanac also, if you notice, very little information is given about stars because there is nothing much to be given. But the moon has got 5 columns. We will discuss the almanac in detail. Moon has got 5 columns because there's too much movement. The declination changing every minute. So there is a slight difference between how the heavenly bodies work. Has anyone seen Venus? Planet Venus?
Yes, sir.
Yes, sir.
Yes, sir.
At sea, you must have seen. It's quite a bright. It looks like a
Yes,
star,
sir.
you know, very bright.
Yes, sir.
So when can you see Venus? At night when it is dark or?
Around 4 o'clock.
Venus you can see generally only in the morning and evening. Venus you can generally see only in the morning and evening. You cannot see during the night. After a long time, you cannot see. Only for short durations you can see during the morning and evening. So my next question is, can you see Venus both in the morning and evening on the same day?
No, sir.
No, sir.
No. Why is that? For some months you can see Venus only in the morning. Then some months you will not be able to see Venus. It goes close to the sun. If you look at this figure, when the Venus is in line with the sun or behind the sun, sometimes maybe you will not be able to see, depending upon the declination also. Sometimes you can see. So all through the year you will not see Venus. You will see for a few months, then you will miss it for a few months, then again you will see. But the point is, when you see Venus as a morning star, you will not see in the evening. You will only see in the mornings for a few months. And then when you see Venus in the evening, you will see only in the evenings. You will not see in the mornings. So when you see Venus in the morning, which side will you see? East or west? When you see Venus in the morning as a morning star, which
East.
side you will see? East or west? East.
East, sir.
East, sir, east.
Okay. And when you see Venus as a evening star, you will see in the
Right.
westerly
Right.
direction. Okay. So I will leave you with this thought in your mind. Read this topic 6.4, study the diagram, and then I will explain in detail before we go on to the Earth and Moon system. So
Okay, sir.
anyone has, yeah, go ahead. What are you saying?
Okay, sir. Okay, sir.
So anyone has any doubt on today's topics?
No, sir.
Elongation
No,
of a
sir.
planet, calculation of the distance from the sun, the seasons, how they are caused, and day and night, how they are caused. Read all these topics once again, go through the video or the diagrams. And when you come on Thursday, be prepared with two answers: the constant of Kepler's third law, the elongation of Mercury, and read about Venus as the morning and evening star so that we understand much faster. Okay, gentlemen,
sir.
thank you for your attention.
Thank you, sir.
So you can take a 15-minute break now.